Now, the questions we want to look at here put together some of the ideas we've got about exact values and right angle triangles, as well as ideas about the four quadrants. So we have to be able to use those ideas that we've looked at before to solve some of these problems. So the first, what we're looking to do is we're going to be given a ratio and told something else about the angle. And then we're going to be asked to find some of the other ratios. Now, the idea here is not to find the angle itself. So we're not aiming to find the angle at any stage here. Your calculators may be good enough to do some of these nowadays, but the idea of these ones is that your calculator wasn't good enough to do some of these because of sometimes we get an irrational number with some of the work. So how do we go about it? Well, we look at what data we've got. First situation, we want to determine which quadrant our related triangle's in. So we've got two pieces of data for this. We know that sine's positive and theta's acute. So if theta's acute, well, that's the first quadrant. So that's pretty easy. The data is telling us it's first quadrant. Then we want to find the cosine and tan of theta. Now, the problem with finding that is that to find cos of theta, we need the adjacent side. We've only got the opposite side and the hypotenuse. So we need to be able to draw a relevant triangle and be able to find the value of x. So if theta is an angle in a right angle triangle, the opposite side is 3, the hypotenuse is 5, because that's our ratio. By Pythagoras' theorem, we're able to work out x is equal to 4, and it's going to be positive because it's in the first quadrant. So that means our ratios would be cos of theta is equal to 4 on 5, and tan of theta is 3 on 4, because the adjacent on hypotenuse and the opposite on the adjacent. So that's how we go about it. So, looking at the other problems. We're told that cosine of theta is negative and theta is obtuse. So that means we're in the second quadrant. So we've identified what quadrant we're in. So finding sine theta, because sine theta, it's going to be sine of theta, and in the second quadrant, our answer is going to be positive. So from our data, we draw up a triangle. We get 5 and 13 as two of the sides, so the adjacent and the hypotenuse, which, if we know our Pythagorean triads, or you need to apply Pythagoras' theorem, we get 12. If you're quite happy, if you know your Pythagorean triads, then you're able to apply it straight away. You don't have to worry about doing Pythagoras' theorem, then that's fine. So, but as long as you know your triads, that's going to help you. So sine of theta would be the opposite side over the hypotenuse, which works out to be 12 on 13. So this one, we got sine's negative, tan's positive. So we've got to think about where sine would be negative and tan positive. So that means it would be in the third quadrant. Now we want to find cosine of theta, which would mean, okay, if sine of theta is the opposite 7 over the hypotenuse 25, then by Pythagoras' theorem, we get the other side being 24. Again, another Pythagorean triad there. So finding cosine of theta, and we're going to be in the third quadrant, so our answer is going to be negative. Our adjacent side is 24 over the hypotenuse 25. Question 3, we've got sine positive, tan's less than 0, which is negative. So sine's positive and tan's negative in the second quadrant. So we'll see we're using those two pieces of data to determine what quadrant we're in, which means cosine of theta and cotangent of theta are both going to be negative, because they're both negative in the second quadrant. So 3 on 5 for theta, if that's theta, opposite would be 3, hypotenuse 5, leaves us with 4 as our adjacent side. So cos of theta is 4 on 5. Cotangent theta would be the adjacent on the opposite, because it's the reciprocal of tangent, which is the opposite on the adjacent. So that gives us minus 4 on 3. So question 4 gives us tan being positive, cos being negative. That gives us the third quadrant. So we identify the quadrant every time. We need to find sine and cos, which means we need at least we need the hypotenuse, because we've got the opposite and we've got the adjacent. So 3 and 4 there leaves us with 5 as our hypotenuse there. And so we are able to get both sine and cos being negative because we're in the third quadrant. And sine would be opposite on the hypotenuse and cosine's the adjacent on the hypotenuse. So we're able to do that every time, as long as we identify our data correctly. Sine is positive, tan's negative. So that means we're in the second quadrant again. And this time, we don't get a nice Pythagorean triad. Our opposite on adjacent, 4 and 7 there, means if we're going to find x, well, that's not a nice set of numbers, but we can apply Pythagoras' theorem. X squared is 7 squared minus 4 squared. X squared is equal to 33, so x is the square root of 33. So that's going to be our answer, our number there, which is approximately 5.8, something like that. It's between 5 and 6, getting close to 6. We're not really worried because we want the exact value. So that's where we want to keep our square roots. We don't want to go with a decimal approximation. So cosine of theta would be minus 33, root 33 on 7, because that's the adjacent on the hypotenuse. Tan would be the opposite on adjacent, which is the 4 on root 33. And because we're in the second quadrant, both are negative. Cosine and tan are negative in the second quadrant. Question 6 has a negative answer for cos and a negative for sine, which means we're in the third quadrant because that's where both cos and sine are negative. Only tan's positive there. The opposite side of, so the adjacent side for cosine of x is equal to 3. The hypotenuse is 8. So working out the opposite side gives us y squared equals 8 squared minus the 3 squared, applying Pythagoras' theorem, which leads us to the opposite side being square root of 55. And that's going to give us tan then being positive, the opposite on the adjacent, so root 55 on 3. Secant's 1 on sine, so it would be, if it's 1 on sine, it's a reciprocal. So if sine's the opposite on the hypotenuse, then you're going to have the hypotenuse on, I'm saying sec, so which would be 1 on cosine, would be the opposite on the adjacent. That's a bit better. So they're taking the reciprocal of the cosine. Cosec's the reciprocal of sine, which would be the opposite and the adjacent. Hypotenuse. So we get our hypotenuse, put it over the adjacent, and it's going to be negative because cosine and sine are both negative in the third quadrant. And our last question, we've got 0.7. Now that's a little bit different. And you're going to go, well, how do I get my triangle from that? I can get my quadrants because tan's positive, cos is negative, so it's the third quadrant. But how do I get my triangle? Well, remember, that's can be written as 7 over 10. And we're looking just for ratios, so we're not really caring about numbers. So that would give us root 7 as the opposite, 10 as the adjacent, which leaves us 149, square root of 149 as our hypotenuse, because 10 squared plus 49, 10 squared plus 7 squared, 100 plus 49, take the square root. So Pythagoras' theorem gives us square root of 149 there. And that leaves us to get cosine of theta, which would be 10 on square root of 149. The sine would be 7 on the square root of 149. Both are negative because we're in the third quadrant. And cotangent would be, well, if that tan is 7 on 10, cotangent would be 10 on 7 because it's a reciprocal of that value there. So, what do we got to remember? We've got to remember the angles in the four quadrants. We've got to be able to apply our ratios to right angled triangles. We've also got to look at and be able to do Pythagoras' theorem, as well as we've got to remember our reciprocal ratios. So they've all come into play in this topic here. Really, we've done this without a calculator as well. You don't need a calculator, maybe just to calculate Pythagoras' theorem, but you're going to have to keep it in exact values. So we're going to have to keep our surds in there. We can't go to a decimal approximation. These questions are always going to say, find the exact value, and that's the nature of the problem, is wanting to play with the exact value there and not having to worry about going to a decimal approximation and staying away from the calculator. So have a look at those ones. Make sure you're able to do those things. Get your correct quadrant, get the right angle triangle drawn up so you can find your missing side and be able to find the ratios that we're asked to get in the problems.